Hi and welcome to GeeksforGeeks. Today we would be discussing a very interesting yet very important problem, that is rainwater trapping problem. So here in this problem you are given an array of non-negative integers, okay, representing the height because height can never be negative, and the width of each block is 1. So just you can imagine that this is the width of the block, this is the width of the block, this is the width of the block, and this is the width of the block, which is just 1. And then compute how much water can be trapped between the blocks during the rainy season. So if this is a wall, this is a wall, this is a wall, this is a wall, then the water can be trapped, 1 unit of water can be trapped this, 2, 3, and then 4 and 5 and then 6 and then 7 and then 8. One important observation is that if you spill water over here, it won't be able to hold. Why? Because the water would be spilling out from this section. Fair enough? Now, there is one more, that is 9 and 10. Again, you can't have any water over here because it would just spill out. So you can just visualize that there is two buildings. One, the visualization is comparatively on this side. Okay. So basically, if you just keep water above this level, it would just spill out. Okay, that's it. Now, the very important understanding in this is that instead of focusing how much water can be trapped between the blocks, you can just visualize how much water can be trapped in each cell. So let's see how much water can each one trap. Okay, so this can't trap any water. Why? Because the outer would always either hold a blank, even if it is blank. Let's say even if it is something like this, let's say this is a wall and this is a blank space, still it can't hold any water because there is no boundary. So one important observation is that the boundary cells can't contain any water, so we can just ignore the boundary cell. So now our point of concern is this one. So now let us see the observe. So this part can store how much of water? This part can store water, this and this. Okay, we have 2 points, which is this and this. So how much water can this one store at this point? So we can say that this point can store water, that is the highest wall from this side and the highest wall from this side. See, if we are talking at this point, we are talking about this part, just this point, how much water it can hold. So we can simply see that this point can hold the maximum, this point can hold the maximum from this side and the maximum from this side. These two are making a difference for this point, and the minimum of that would be my value minus if this had a height of this. So can we say that this calculation is comparatively simple on if you move from the left hand side, the max height that came in was 3. If you move from the left hand side, the max height of the wall that came in was 3. If you move from the right hand side, the max wall that came till this point is how much? 1, 2, 3, 4. So the minimum of that, then only you can store water. Let's say this is the idea. So the minimum would influence it. So I would say, okay, I can keep 3 blocks of water. But now the point of concern is what would be the scenario if this is not an empty cell. So that is why we also need to consider this, that whatever be the minimum from left and right, we also need to subtract the current, that is 0. So we have 3. Yes, it can hold 3 amount of water. Now let us just see again for this element. Okay, so the maximum from that side is 4 again, 3 again. So again 3, but this time it would be 3 minus 1, that is 2, because this is getting influence. So yes, this is holding 2. Now let us do for this 3, and from that side, how much is the scenario? The scenario is that it is 3 and this is 4. So I can simply say minimum of that minus this. Yes, it is holding 3. So I got a pretty good idea about that. Now I understand this question. Now the basic idea would be that I would stand at each point, get the maximum from the left and maximum from the right for everyone. And then I would do a what? Minimum of max left minus max right minus the current element. Now, Siddharth, can we generalize this more? Because it was the scenario that didn't compute for this. So can I generalize this more? So see, how can we generalize it? If I stand at this index, then the max from that side is how much? This side is 2. And the max from this side is how much? 3. So minimum of 2 and 3 is how much? 2. And then if we subtract the current element, that is basically 2 minus 1, 2, 3, 4. So that is minus 2. So if we add minus 2, to our result, then it would disrupt it. Why? Because we know that we can never hold negative water. Like we can't hold negative water. So what we can say is just we can generalize this, and that would be same for everyone. That if the computation of this is greater than 0, then only we would do answer plus equals to this value. So now the idea is that for each I, we would go from 0 to I minus 1, and we would go from I plus 1 to n minus 1. We would compute the max from this side and the max from this side. That is why for each index, because practically leaving that one index, this would do half of the work, this would do half of the work. Or if this is doing 10% of the work, other work, leftover work would be done by that. But all the indexes would be iterated. Like one index would be iterated by this, and the leftover indexes would be iterated by the summation of operations by these two. So I can say that the summation for each index, for one index, for calculation of one I am doing big O of n operation. So for calculation of n i's, I would be doing big O of n square operation, and the space complexity would be constant because we are not using any auxiliary space over here. Everything we are using is just variables, and variables don't contribute to big O space complexity. That makes sense? Now let's have a new test case. So for this test case, the answer is 9. So do we really need to stand at each point and find the minimum every time? No, not at all. What I can do is, I can just compute the maximum till the current point. Let's say this is nothing but max left, and this is max right. So max left would be that we would simply start from this point, this point, this point, and we would go till this point. And max right would be go from this point and this point. Now let us see if we are getting the answer or not. So if I start from this index, this would be 2. Maximum till this point is 2, 2, 2. Then we saw 5, which is greater than 2. So we would update. And then we saw 3, which won't affect the maximum. Then we kept it. Then we kept it. And then we kept it. Now for the MR, we would be standing at that index. So that is how we would be building it. So from n minus 1, we would start iterating. So maximum till this point was 4. Then it would be 4. 1 won't affect the result. 1 won't affect the result. It would be 5. 5 won't affect the result, and it would be, now can we compute the result? Let us see that. See, only this would be there to store the values. Okay, so we would be only computing for these values only. Okay, because they would be the one who would be able to store values. So the minimum from the left is 2, and the 2 and 5, the minimum of that is how much? 2. The minimum of 2 and this one is 2 and 5 is 2. 2 minus 1 is equals to 2. 2 minus 1 is equals to 1. So this would contribute to the result. Then we have something like maximum of left before it and maximum of right from that side. 4 minus 2 is equals to 2. 2 minus 5 would give negative. So that is why this won't contribute to the result. I told you an if statement now, that if that value is greater than 0, then only we would contribute to the result. Fair enough. Let's move forward then. Next we have up is 5 and 4. Minimum of that is 4, and the element located is 3. So 4 minus 3 is equals to 1. So this would also contribute to the result. Then we have, for this element, we have 4 and 5. 4 minus 1 is equals to 3. This would contribute to the result. Then we have 0. So the maximum of minimum of 4 and 5 is 4, and 4 minus 0 is equals to 4. So 4 plus 3 7, 7 plus 1 8, 8 plus 1 that is 9 itself. So this is how we would get the value. So this is working. And how much time would be required to build up this array? That would be big O of n. That would be big O of n. And how much calculation would be needed? So I would stand at each index. I would refer to the max left of previous index and plus 1 of right index for ML and MR. And we would only compute for these all. So accessing and doing arithmetic operation also contributes how much? Constant. So for calculating one index, we are doing constant operation. So for calculating n index, we would be doing big O of n operation. So for calculating one index, we are doing constant operation, and for calculating n index, we would be doing how much? Big O of n operation. So now the time complexity is big O of n, and the space complexity is also big O of n, because we are using two auxiliary arrays. It is basically 2 multiplied by n, but ignoring the constant, it is big O of n. So now we have space complexity as big O of n and the time complexity as also big O of n. Now let me show you a very important observation by which we can suppress the result. So now first see this, then I would explain how this works. So we would have two pointers, that is left and right. I hope this makes sense. Now what we would do is, we would first compare the values. The values are 2 and 4. The minimum how much? The minimum of them is 2. The minimum of that is 2. So now see, up till now, whatever was the max left, we received it. And yes, this is true. But what about the max right? What about the max right? We only know the max right till this point, but we are unaware of this. And yes, this is true. Here we are saying the max right is 4, but the correct answer is, up till this point, it has becomes 5. So what can I think of? See, the idea is, I would tell you the idea. So now see, we are unaware, we are not considering these all elements. But the point is, should we really consider these all elements? Will the value change by any instance? So up till now, the minimum of 2 and 4 is 2. So now if we make this r go this side, then will this minimum change? Because if we go on this side, max would never narrow down, na? Max was 4, it would remain 4. It has only option to increase it. If we are calculating max till this point, and if we increment it, if we calculate max till this point, 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 what do we want? Our concern is getting the minimum of left and right. So if we move r this side, the minimum won't change. Yes, this might, from 4 it might become 400 also, but our concern is what? Minimum. That is why modifying the r and making it consider all this statement is of no use. So what we can do is, we can simply say that yes, the minimum up till this point is 2. So 2 minus 2 is how much? We would consider whatever was the minimum. Now we can just consider that this value was the minimum. Left was the minimum. So now we would do the computation for the left. Whatever is the minimum, we would do computation for that. So now we did the computation for the left. So now we can say that 2 minus 2 is equals to 0. So this index would contribute 0 to our result. Let's move forward. Whatever is the minimum, we would move that only. Whatever is the minimum, we would move that only. So max of left up till now was 2. Max of right up till now is 4. We would also maintain a variable and a left and a right pointer. Again we moved forward. Now again we move forward and we would update the MLR accordingly. Whatever is the scenario, at this point, who is smaller? 2 is smaller. So again we would do the computation. 2, minimum of 2 and 4 is 2. So we would do the compute. Who is smaller? L is smaller. So we would do the computation for L. So 2 minus 1 is equals to 1. So this would contribute 1 to the value. Now what was minimum? L was minimum. So we would make the L move forward. Now L become how much? L became 5 because 5 is greater than what was already there, that is 2. Now 5 and 4, which is minimum? Right pointer is minimum. So now we would do the computation for the right. So 4 minus 4 is again 0. So after we are done with the computation, we would move forward. Then at this point, who is minimum? Again 4 is minimum. Okay. So we would see. Again we would do the computation for the right. 4 is minimum. So 4 was what? For right. So 4 minus 0 is equals to 4. So see how we are closely getting towards the answer. So this 4 was contributed by m of r. So r would increment. R would now increment. Again, did r increase? No. We are still seeing 4 only as the maximum till this point. So again, 4 would suffer. So 4 minus 1 is equals to 3. So this would contribute 3 to the result. We did the computation for m of r. So r would move forward. Now again, okay, 4 has not increased. Again we are doing the computation for m of r. So 4 minus 3 is equals to 1. Fair enough. Again we did the computation for r. So r would increase. L and r are now pointing to 5 and 5. So minimum of that is 5. 5 minus 5 is equals to 0. So if you observe, 4 plus 3 7, 7 plus 1 8, 8 plus 1 is 9. So this is how we are getting the result. So the pseudo approach would be that we would keep a variable m of L initially to 0 and m of r initially to 0. We would compute two pointers, L is equals to 0 and r is equals to n minus 1. The first thing what we should do is we should first update the m of L and m of r. How we would update? So m of L is the maximum of what was already kept and m of L. M of r would be updated the same, max of whatever was already kept and m of r, whichsoever is smaller. If m of L is smaller, we would compute the contribution from that and we would move m of L on the right hand side, that is L plus plus, and same goes for right, that is right minus minus. We did that and we would keep doing that until they freeze at a particular point and they don't cross each other. If they cross each other, we would again do the computation for the same one. That is why just computing again won't be any use. Let's see the code at this point. So what I did was left is equals to 1 and right is equals to n minus 2. Why? Because we know that the water would be contained from the second element to the second last element, and left would start from the first element, right would start from the last element. This is how I did. We would keep doing that until they don't cross each other. So if right max is less than left max, we would update the result if it is greater than 0. So if it is negative, then we would only take 0, add 0 to the result. If it is positive, then only this would get added. Now then we would update the max and then we would shrink the right pointer. Then same goes vice versa. Whatever is the positive contribution, we would add that, else add 0. Then we would update the left and then we would make the left go this side. Whatever came up, we would just return that. Now let us talk about the time complexity also. We are not using any auxiliary space, so the space complexity is constant. And talking about the time complexity, if you see that each point is either visited by left or right for just once. So the time complexity is big O of n, because we are visiting each position exactly once. We are not using an auxiliary space, so the space complexity is constant. Now let us see if this approach works or not. Now let us just compile and run and see how many errors are we making. Seems like no error is being made. And yes, we got an AC. That was it from my side. Thank you and have a nice day.